All right, hi everyone. So in this video, I will talk about section 3.7, which is the derivative of inverse function. So let's talk about the inverse function first. Um, if you still remember how do we find the inverse function, right? So you have y, for example, if I have a function y equal x cubed per 3, to find the inverse of this function, we can make this become x and then replace x become y. And then from that, we isolate for y. So you have y cubed equal x minus 2. And then y gonna be the cube root on both sides, x minus 2. So this is called the inverse of the function f. So if my function f(x) is equal this, then my inverse function will be cube root x minus 2. All right, so this is the inverse function. And we can, of course, make the function become an inverse and take the derivative from this inverse function. Yes, for sure. But the problem is there is some equation like this. It's really hard to find the inverse. How do we gonna find the inverse function and then take the derivative from that? Okay, so it's gonna be really hard from this. So that's why we're gonna have to work through a formula where we can find the derivative of the inverse function without going through this step. Okay, so how do we do that? So first of all, we're gonna start with an inverse function. So I'm gonna call y is an inverse function. Okay, I'm gonna call y is an inverse function. And to take the derivative of this function, then I'm gonna have y prime will equal to f inverse prime of x. Okay, or the inverse inverse prime of x, or if you want to, you can also write at let's see. You can also write that f inverse of x and then the whole thing to the, prime. Okay, so this is the derivative of the inverse function. Or we can also write that df inverse of dx. Okay, so this is going to be mean the derivative of the inverse function. And we want to find a formula of the derivative of inverse function. And keep in mind one thing, inverse function is found from interchanging the x and y. So y is f inverse, mean x gonna be f of y. Okay, so y is f inverse, then x will be f of y. The input of the inverse function is the input of the inverse function is the output of the original. Okay, so they just interchanging x and y. And now how we're gonna find the derivative of this equation. Okay, so to find the derivative, I'm gonna take the derivative on both sides. I'm gonna apply derivative on both sides. Now what? When I apply the derivative on both sides, isn't that the derivative of x gonna be 1, right? And on the right-hand side, what is the derivative of f of y? So derivative of f of x is f prime of x. Okay, but if you remember, we talk about chain rule. What is the derivative of f of u with respect to x? Isn't that you're gonna have f prime of u times u prime, right? It's gonna be the same thing for this. This also f of y. Y is can also consider as u, right? So it's not the variable x. So this is the function that have a chain rule. So we're gonna have f prime, if we apply the chain rule, we're gonna have f prime of y times y prime. F prime of y times y prime. And our goal is to find y prime. We want to find y prime, so our y prime will equal to 1 over f prime of y. And that actually gonna be f prime of, and y is equal what? Y equal to f inverse of x. And that definitely the derivative of inverse function. So y prime, or the derivative of inverse function, is actually equal 1 over f prime of inverse function, of the output of inverse function. Okay, so here we want to find y prime. So this gives you y prime is this, and we want to find y prime, and we end up having the y prime is 1 over f prime f inverse of x. So, and y prime is the derivative of f inverse, so you can generate down by the inverse function theorem. If you have a function f of x be a function that is both invertible and differentiable. So it means f of x can be differentiable and invertible. Then let y equal f inverse of x be the inverse function. For all x satisfy f prime of f inverse of x cannot equal to 0, then the derivative of the inverse function can be written into two different notation. It's actually 1 over f prime of the output. Okay, so y is the output of the original function. So the other way to think of is the derivative of the inverse is 1 over f prime of the output of the original function. Okay, so if we let's add g of x is equal f inverse of x, this can be also written back at f inverse prime of x, or g prime of x is equal 1 over f prime of g of x. Okay, so the notation can be rewrite or replace back and forth, depend on how you want to label them. It's just easier for us to use when we solve the problem. Okay, so let's take a look at how do we solve example 1. So the function f and g are both differentiable, and f and g are inverse of each other. Okay, so we want to find the following. If the function f of 12 is equal 4, so when the input is 12, the output is 4, and f prime of 12 is negative 5, can we find g of 4 and g prime of 4? Okay, so what is g of 4? G is the inverse of f. G is inverse of f. So it means f of 12 equal 4, means g of 4 will be 12. Because inverse is the interchanging between x and y. So f of 12 is 4, then g of 4 will be 12. And now what is g prime of 4? G prime of 4 is going to be equal to 1 over, if we use this formula, we're going to have 1 over f prime g of 4. Okay, and we already know what g of 4 is. G of 4 is 12, so it's going to be 1 over f prime of 12. And everything is just there. You have f prime of 12 is negative 5, so 1 over negative 5. So that is how we solve the problem using the formula. Now let's try one more time for the second one. So I have f of 3 is negative 2. The input is 3, output is negative 2. Then what is g of negative 2? G of negative 2 will be 3. They just interchanging between x and y. And now what can we find g prime? G prime of negative 2 is 1 over f prime of g negative 2. And we know g negative 2 is 3, so it means 1 over f prime of 3. And the problem also provides you f prime of 3 is 5, so it means 1 over 5. That is the derivative of the inverse function. Okay.